so it's pretty loud. There we go. Alright. Let me generate some video URLs, copy that, and share it into Discord. Alright, just sharing the link. Alright, let me share this in r/redstone. Where should I put the videos? I should probably go back through the live streams and redo the thumbnails. Right. I didn't even post this on my own channel yet. There we go. And then to share this in here. And then I'll share this into Wall Street Bets. Yeah, post it in Wall Street Bets, because you gotta do that. Hey, General. I'm not sure what you mean good luck on. I appreciate it though. Let me just share this into Project Showcase. Live right now working on my assembler. Okay. If the music is too loud, let me know. If it's not loud enough, I could turn it up. Hopefully this music doesn't get the stream pulled down after it's done. It doesn't like how high the video resolution is, or the aspect ratio, I guess, whatever. I guess we'll deal with it. Anyway, so I'll show you guys what I have so far working. So I have this assembly. Oh, okay. First I'll show this document here. Okay, so this is the instruction set I think I'm settling in on for this architecture. So there's going to be a 25-bit instruction. Instruction bit width is not a penalty to me in the CPU because of the cobblestone downward wiring is in a single like game tick or instant or however it's calculated, whatever. Like adding more bits here doesn't give me a speed penalty, so I can make this as wide as I want really. I just happen to settle in on 25 bits here for the instruction set. So the idea here is I'm just going to give the instructions what they need for the ALU ops separate, and the way it'll work is like line 4-bit op 0 is like if you put in 0000, you're doing an arithmetic op. Well, how do you know what arithmetic op you're doing? If you have nothing in here, you're doing add. If you put a 1 in there, then you're doing subtract. If you put a 1 in there, then you're doing right shift. So 0 is add, 8 is right shift, or is sub, and 4 is right shift. If you're looking at it as a 4-bit number, right? Now in logic, if I wanted to do like OR, I just basically have my control logic for my ALU hooked up here, so I could do not A, not B, or flood carry. So if I wanted to do OR, I would just literally flip OR. If I wanted to do AND here, I'd look up this table. It says put a 15 here, so I'd put a 1 there. So the functions where they're encoded in the instruction set, or in the assembler, will just look like a 4-bit select, an 8-bit immediate, 3-bit RS2, 3-bit RS1, 3-bit RD, and a 4-bit op. And then those will get like set next to each other when the instruction is finally decoded, and then it would print that line. Now the assembler that I have, that I'm working on, does two things, which is nice. It generates the assembled file, which is obviously goal number 1, and goal number 2 is it generates a listing file. which basically shows you the assembly and then how it's broken down to machine code. So when you're debugging and you want to see if something's working or isn't working right, that's a nice debugging tool. So for instance, here is some the mnemonics for these instructions here without any pseudo ops. So this is everything it can do without adding pseudo ops to expand what it can do. So I have add. So all these mnemonics here take either an immediate or an RS2 as a second source. So because of that, you'll often see two sets. Sub doesn't need an immediate given, because like sub immediate is the same as doing add immediate, but putting in the immediate as negative. And since you have access to the full 8-bit number, you can interpret it either as a really large number or as a negative number. It's up to the user on how they want to. So like sub immediate is like kind of redundant and useless, but for consistencies I can just do this. It's in there because the assembler can do it, but it's stupid and it's not needed. Anyway, so like if you didn't have access to a full 8-bit immediate, then sub immediate would make more sense, because then you'd have to sign extend, or no, you would even sign extend. No, it still wouldn't make sense. Anyway, so moving on. So like then I could right shift. So if you look here, these mnemonics are 1, 2, 3, 4 arguments. So these are 4, and right shift is 3 arguments. So in the assembler, it'll throw an error if you tell it too many arguments. For instance, if you told it to add and only gave it 2 arguments, the assembler would tell you there's an error, and the error is that you don't have enough arguments for that instruction. And the same thing happens with right shift. If you try to give it 3 arguments thinking it's kind of similar and somehow confusing how it works, because it's not a barrel shifter, it's literally just right shift RS1 and store it to RD. So you put in more than 3 arguments here, op, destination, and source 1, it's going to throw an error because there's no need for any other information on that instruction. And the error it gives you back is kind of nice, so it tells you like what the error is, so like you can know where to hunt for it. Then yeah, so all the logic ops have 2 versions of it, either the RS1 plus RS2 or RS1 plus immediate. Same with so NOR and NAND and XOR all do the same thing there. I'm writing in Python. I'll show you that next. I'm just going to go over like if you don't know how the instruction set works, there's no way to know how to write the assembler. So like I already implemented all these ALU mnemonics, so I can test it with that, and I'll show you guys that next. But so here's some compare mnemonics. So the idea here is with set less than, it's signed. So if RS1 is less than RS2, so if this is like -3 and this is 5, that would be true, and then it would put a 1 in the destination register. If it's false, it would put a 0 in the destination register. And set less than unsigned would then see this -2 or negative value or whatever you put in here as a very large positive number, and then it would automatically think this is bigger than 5 if you put in -2. So there's a signed and unsigned compare, and that's how the user can determine, you know, if they want to be using a signed operation or an unsigned operation. This is where you get that from. If the music is too loud or anything, or not loud enough, if you guys have any suggestions, feel free to say. So then I have branch mnemonics. So the branch works, I actually have 2 branch instructions. I have a 3 and 4. So these branch instructions here, the top one is 1 operand branch and the bottom one is 2 operand branch. So what do I mean by that? Since compare already does A less than B, signed and unsigned, the only branches we need then, because we could check if a register is equal to 0 or not equal to 0 very easy. That's a very easy to check. It's just a decoder on a single line. Is it 0 or is it not 0, right? So with set less than, putting a 1 or a 0 in that destination register, it makes doing branches on that so easy, and you get the speediness of splitting it up into 2 separate instructions still. So that's what the reason this is a powerful instruction set is because branch if okay, so I'll explain it. So branch if equal to 0. So is your single source equal to 0? If it is, then you branch. If it isn't, then you don't. Branch if not equal to 0. Is it not equal to 0? Then you branch. Branch if greater than or equal to 0. Branch if less than or equal to 0. So the idea here is you can just check your input on a single line really easy. Like if it's greater than or equal to 0, then you just OR all the lines together, and it can either be 0 or not 0. And then if it's greater than 0, you obviously know, like if it's a 1 or a 0 on that line, it doesn't matter. Like on the subtraction line, like on the results. Like so these flags are just really easy to check for. Branch of not equal to 0. So this is it's similar to here where you're only looking if it's 0 or not. You're not also looking to see if it was greater than. Like these are just really easy decode operations. And then branch if equal and branch not equal is a 2-operand branch, but it's not expensive because you don't need a subtraction. Branch if equal and branch not equal is just an XOR. So this is a cheap operation, and then these are really cheap operations. So they're quick, and that will fit in the 5-tick pipeline that I need. I can't afford to be sticking like a subtractor in there and then checking flags, right? Like, no, the whole point of the set less than instruction is the set less than instruction gives you access to the flag information without needing to store flags, right? So you'll see like there's no flags on here because you don't need a carry out and an if 0 and all these flags generated like most people do in a CPU. If you use a set less than instruction and can store that flag that you're looking for, whether A is less than B signed or whether it's unsigned less than B, like you can store that as a 1 or a 0 in any destination register, and then easily check that destination register for a 1 or a 0 in the next operation. So that is very, very powerful. So anyway, moving on to the branches. Branch of equal to 0. What is equal to 0? If RS1 is equal to 0, then I'm branching to what the immediate says. But I'm not branching to the immediate. I'm branching to the program counter the current address where this line came in, plus the immediate. So they're relative. That's why it says up here in the instruction set, signed 8-bit relative branch. The branches are relatives and the jumps are absolute. This allows for code to be moved around in the program file, and the branches will still execute, and the jumps, since they're absolute, those program functions won't change where they are. Just how you're calling them may change when you're rewriting your code. So that's the idea there. So you can build a jump table about where all of your instructions are from, and the jump table works via the jump register mnemonic or the jump and link register mnemonic. But anyway, so like I said, branch instructions are 2-operand here, and then there's single operand because it just needs one thing and then where it's going. So that's just 3 total operands for the instruction. And then 2-operand branch needs 2 sources, which is why it's called 2-operand branch, and then where it's going. So like it's really 4 total operands because you need the instruction and whatnot. But in terms of the branch itself, it's 1 and then 2-operand. Like that's why it's called like that. So I have 2 separate instructions for that. The instructions are 3 and 4. And then I can tell it what it's doing based on that table there, which is very easy to decode because there is no decode. Those just go to control lines. Very easy. Alright, so jump mnemonics. This is jump, and then jump registered is below it here. So obviously jump jumps to the line that the immediate specifies. So if you jump to 255, it goes to line 255. It's not going to where you are plus 255. The jump is absolute. Jump register, it will jump to the address contained in that register. Oh, that should be RS. Oh, I'm glad I caught that. That should be RS2, I believe, is what I'm going to use for that, actually. Jump register. Yes, I'm using RS2. Okay. And then, so the jump is obviously going to the immediate line. Jump register is going to where that source specifies. Jump and link is going to the immediate and putting the program counter address plus 1 in the return destination, or the return in the return register, destination register. Sorry. So what it's doing there is that's allowing you to do a subroutine, right? If you're storing PC plus 1 to the return address, which is RD here, or actually we'll call this RA because it's I don't want to get the notation confused. Actually, in the assembler, it'll automatically fill that in with RA if you don't specify. That's what I'd like that to do. But if you do specify, then it'll be RD. It'll be whatever you specified as RD. But RA means return address, which is mapped to 7 in my instruction set so far. And then jump and link register, where you're jumping and linking RD, but the jump address comes from the source. So that's like a jump table. So you can have like a jump table set up with all your functions, which is how like in C++ a switch case statement works. And then lastly, we have the RAM mnemonics. So the idea here is load word. The idea here is being able to do stack pointers and just any sort of pointer operation really easy. So for instance, load word will take the address in RAM held at RS1, so like you load the register RS1, add to it the immediate, and that address is where it gets the data from RAM or it stores the data from RS2 into RAM at that address. I'm sorry, because this is load word. We're loading. Do I have this backwards? No, load word should be RD. Yeah, we're loading a word to the registers, and we're storing a word to RS1. Yeah, I had that backwards. RS2. That's what that is. Yes. Yes, that's 7. So I copied this from a different instruction sheet. I made it a new sheet and I accidentally cut. Oh wait, no, I didn't. It was sitting here. Wait, why is it starting at B? Oh, there we go. Okay, that was weird. There it is. So, load word is this one, and then yeah. So load word uses. What the hell am I thinking here? Load word from memory. I have this backwards. See, it's good to go through this. There we go. And then load word would need RD. Okay, so I think it would work like that, right? So load word, we're loading the word from RAM that's held in RS2 plus the 8-bit immediate, and we're storing that to the destination register. Okay. Alright, so I could say like a pseudo instruction, or like an instruction could look like, oh my god, that's really small. Alright, so I'll just copy this. So an instruction could look like this: load word, the return address register, you know, or temporary 0, for instance, could get, so 5. And then this could be like stack pointer. And maybe I want to start, maybe I'll make the assembler need registers to be specified. Yeah, okay, that's what I'll do. I'll make registers need to be specified, like with the $sign as a register. Hey, nice to see you back. Dashes. I'm going to call you dashes because I don't know what else to call you. Yeah, so for instance, this could be an instruction where it's saying, go 5 paths to stack pointer and store that RAM location into register T0. So that's like what it could do. And so instead of a stack pointer, you can make that the frame pointer or the global pointer. Like, so that's how that's going to work. And then store word, for instance, would look like we're going to store into the saved register 0, and we'll have to make it specified with a $sign. And we can even use binary 0B 0011, and we wouldn't even need to put the zeros in there. We could just do that, and then here we could put a frame pointer. All right. So this is how the instruction would look like. Oops. This is how the instruction would look like, and then this is like the general case, like the formatting for that instruction. So getting this to assemble is going to be tricky, like having it search for the immediate and then note like that it's got to be in parentheses. Like, so I'm going to have to do some parsing for those, because I don't want it to be like in this format for that, because it doesn't make much sense in this type of format for the load word and store word instructions. This makes more intuitive sense. But yeah, the assembler will be able to interpret between them. So now I'll show you what I have for the assembler. Okay, so this was written a little while ago for a different risk instruction set I was working on. And so I just adapted this to being able to work for this because it should work for any risk instruction set. It's really easy to adapt. So all this bullshit here does is allows you to ask the user to like where's the file, what you want to do, and how you want to assemble it, so you can get a binary out of it or a listing file out of it, and it'll ask you, and then it will do that kind of deal. So anyway, so here it opens up the input file, does all the input file crap. We're asking like you know, what format you want, but here's where some functions get defined. So like for instance, we have a conversion function where we're able to convert from, you know, a base to a base or something like that. Here we have a convert to integer, where it converts it to an integer in that base. Dasha says, I'm working at a tech internship, and for our final project in the course we had to come up with a project, and me and my friend decided that we would do blackjack, but for the house. I then rewrote, oh boy. Here's a cool function, xlen. So what it does is it creates a string of length x that's of the correct bitwise format. So it takes a decimal integer and converts it to a binary. He says he then rewrote most of the code in the binary in about a day. Same thing with connect4. Nice. That's good experience. So this function is really cool because so you pass to it the bit width, the value you want to convert, and then if the sign is true or false. So by default the sign is false. So for instance, if you had 10 bits and the value of 10, and the sign was true, they would know the most significant bit of that bit width was the bit, you know, was the sign. And if you put in -10, it would format it the correct way. If you put in 10, it would put it the correct way. If you tried to put in a value of negative when the sign was false, it would throw an error. So that's what this does, and you can see the error. Value over, value under, val over, val under. So if the sign, if there's no sign, and then like what to do with it each case, and then how to format it. So here is where the registers are defined. So the return address register is 7, stack pointer 6. Then what I do is I have A0 and A1, which are two registers that pass arguments into subroutines. V0 is the return argument from the subroutine. T0 and T1 are scratchpad registers, and then R0 is the return, or is register 0, which always outputs 0. So if you type in R0, it would encode 0 into the registers, into that column. Yeah, I'm not going to rewrite that, but I appreciate the advice on that. So then here's the definition for ASM to int. So this is taking the ASM line and converting it to like into like discrete like things that can be looked up. So it's like doing the split operation, storing them in this arguments register, or into this arguments array. So for instance, then when I get into, and like if it's not, whatever, it's not appropriate, if it's not done right or whatever, it'll fill, or no, anyway, after it does this, it just fills all the outputs that it can be possibly true with 0. So for instance, the opcode gets 0, RD gets 0, all this shit gets 0, so it's basically a no op. So it just presets those values ahead of time. So then when you come into here, like you can start decoding stuff. So like for instance, if the 0th argument in that was add, you know, if that was the first mnemonic, then if the length of that is not equal to 4, like we only want 4, the add, the destination, the source 1, and the source 2, or the immediate, right? So that's only 4 arguments that we want. So if it's not 4, we're just returning zeros and everything. And I can spit out an error there if I want, like raise value error kind of deal here. Like actually I can. I should probably do this, to be honest. Raise value error. I don't know what to call it, the error yet, and the error number, and then we'll call this argument length does not match instruction requirements. Yeah. Okay, and I'll save this. Now, in the test ASM instructions, I have a bunch of shit. I'll just move this down a little bit, and then here, if we put in, so we just tested, we just did something on the add instruction. So let's say we did add T0, T1, T2. No, I can't do T. S0, A0. Right, this should throw an error. So when we try to run this, down here it's asking for the input file. It's called test.asm. Let's generate a listing file, and throws an error. Oh, it already does. Yeah, too many values to unpack. Okay, so I didn't even need to put that value error in there. It's already doing it. Let's go into line 288. Oh, here's where it does it. Okay, so yeah, I don't need this here. Anyway, so now if I come back to this, delete this line, save the file, run, type in test.asm, we'll get a listing file, run it, and now the listing file should be nicely formatted. Yeah, so you can see it ignores the comments. Test a comment, there should be above, yeah, so I don't know if I want the comments to go in there or not. But you can see here, this is now like a, so we can see like add here, 0, 0, and 0, 0 there. And then if we go to subtract, 0, 0, but then it's the 8 to put there. Yada, yada, yada. So the way that's achieved of putting these the right bits here is using that xlen function at the end. So the binary the full binary instruction is whatever you decoded as the opcode, it has 4 bits and no sign. Whatever you decode as RD, it has 3 bits and no sign. RS1 is 3 bits, no sign. RS2 is 3 bits, no sign. Immediate is 8 bits, no sign. And select is 4 bits and no sign. It joins all that stuff together, and then at first it like depending on what you want, if you get the binary file, it doesn't put spaces, and if you get the listing file, then it makes it look nice like that. Take care, dashes. Did all of her extensions end? Okay, very good. Okay, so now what I gotta do is get these instructions uploaded up to a different screen. So now I actually have to go through and get other things other than arithmetic working, because I know arithmetic now ensembles. I guess I'll leave some, whatever. I'll leave the add up there at the top. So we've done all the arithmetic, and so I will go enter here. Nope. Should put a hashtag. Okay, so now we're gonna do like, so we did arithmetic logic ops. What are we gonna put here? This is gonna be compare. Move that down. Okay, so compare. Let me just make sure that all these arguments are right, because the shift should be 3. 3, okay, cool. Okay, so this is how I implement a new instruction. in the encoder or in the assembler. I just copy paste the previous one, change this to the mnemonic I'm looking for, which in this case will be set less than. Set less than has 4 arguments, so if it's not 4, I'm returning 0. The opcode for set less than is 2, so this becomes 2. The destination register is still the first argument, then source 1 and source 2 are the second. So it says second here, that, and select needs to become, for set less than, select is 0. Okay, but now if there was an immediate there, we're going to grab that, select the immediate. How do we do this? So if there was an immediate, I may need to, let's think this. On set less than, am I going to have to worry about, no, if I just don't put in a RS2 source, it'll load zeros on the register, so I don't need a mux there. Okay, that's fine. And the assembler will only fill in the immediate. Okay, yeah, that's fine. Okay, so we can do that. So what we're going to do is the third argument, if it starts with 0x, 0d, or 0b, we're going to convert it into integers using that function that we wrote before. And it's going to return that as immediate. If it's too large, over 8 bits, we're going to say an error, and then RS2 will get 0, so it doesn't load itself. If the immediate wasn't true, then RS2 gets, you know, the third argument, which would happen to be the register source, and the immediate would be 0. Okay, so that's set less than. Now we got to copy this and do set less than unsigned. I don't know how that got. What? So now we're going to say set less than unsigned. And so what's the difference? Oh, so there is no immediate. Oh yeah, I don't know what I was doing here. This should be RS2. Okay, so there should be no immediate on the set less than or set less than unsigned instruction. So if return 0, 0, 0, 0, 0. And if we do that return 0, 0, 0 thing, it should throw the right error, I believe, hopefully. Yeah, and then we don't need to check if the immediate, we don't need to do any of that. We're just going to do this. Alright, and then I'm just going to copy this and paste it over this. What the hell? Control C, Control V. Okay. Alright, so now we'll make that set less than unsigned, and the only thing that changes is, if you look here, set less than unsigned, instead of this being a 0 in the 4-bit select, it becomes a 8. So the opcode is still 2, and then the select becomes 8. Alright, so I kind of want to see if this works. Okay, that was fine, but now if I put in, yeah, set less than T0, well, no, saved register 0, T0, T1, that should work, and that should assemble. Test.asm list, why is there no save 0? Because I'm dumb, I don't have a save 0. Okay. We'll make that a... I don't have any saved registers. Okay. That's kind of shitty. Run. Nah, I just clicked the wrong thing. Run. Test. This should work now. Listing file. Okay, so you see here, we were able to assemble that, but now I want to test putting in an immediate here. That should not work. It should not do anything. So we'll go here. I'm going to reorder this so it makes sense. And then here we'll put in 0x05, for instance, and then now we'll try to rerun this. Type in test.asm, listing, boom. Okay, I generated an error. I don't really like the error, too many values. And it doesn't tell you what line of code the error is on, so okay, so there should be some better error throwing. But to get a functional assembler up, like, I'm not going to worry about that. We'll get the assembler working and add on that error checking after. Okay, so I knew that would throw an error. Okay, let's call this T1. Okay. What are my registers? Stack pointer, those are saved. Oh, okay. Maybe I should make an S0 and a T0. That doesn't really make much sense. Yeah, I wish I had more registers. I might just make this not dedicated stack pointer and just make this a saved register. Yeah, and then you can make that like a stack pointer or whatever you want. And maybe I won't make that a return address, I'll make that saved 1. So you can make this and this your pointers if you want to save them. And then it won't recognize RA, you just have to put in, like, yeah, because, yeah, okay. We don't have a lot of registers here. In MIPS register set, we have 32 registers to work with. Here we have 8, right, with the 0 register, and the MIPS is 32 with the 0 register. So really 31 versus 7 registers. So we're a little limited on our interpretation of the MIPS instruction set there. And well, we basically have the instruction set, like what it can do, but not with all the registers that it has. So it makes doing things a little bit trickier. Okay, so we're down here to set lesson assigned. Let's look at the listing file. Oh, let's run this again. Test.asm listing. Okay. So we can see that it should generate a 2 for the instruction operation. It puts the register destination, source 1, source 2 in their correct spot. There's no immediate, and there's nothing there. But now if I did set lesson unsigned, it should just with the same everything else, it should put a 1 there. So we try that now. Set lesson unsigned. Run. Test.asm list. Okay, and now if we look, the only difference is it put a 1. Whoops, it put a 1 there. And so this is the full binary instruction there that you would see. Let me just check my Discord DMs. Alright, so Aperture gave me a suggestion on how to do the... Okay, so there's one thing I kind of wanted as like a neat feature of this is, you see how much space there is between this? What I want the assembler to also be able to do is see how many characters are in the instruction. Pad it with a few zeros, so like find the instruction with the most characters in it, pad like 3 zeros on it, and then do this here, like put this stuff next to it so that it's adaptive to the longest instruction you type, or the longest comment in there or whatever. Like I want it to like ignore the comment and then just move on to the next. Ignore the comment length when counting that, because the comment would be its own line with nothing to parse. But yeah, we'll get there. Alright, so the other thing I want to do now is actually come back up here and force registers to be named like this. So now if we try to run this, it's not going to work. So now what we need to do is we need to put in register values with a $sign. Now, ah shit, did that in the wrong. Save it, run this. Test.asm list. Cool. And now it works. Okay. I like the $sign because that makes it know that you're doing a register. I don't know what the fuck that is doing here. Save that. Okay. So we did compare ops. I don't know why it doesn't paste where I told it to. And these will be branch ops. So these should have all been 4 arguments. Yep. Now the branch mnemonics are going to be similar to that. So we'll copy that set. Okay, so we'll change this to branch if equal to 0. So the first argument is rs1 and the second argument is rs2, but the thing is here that these are 3 total arguments. The branch, the source, and then where it's going. So if it's not 3, we're returning zeros immediately. The opcode for this is a 1 operand branch, which is going to be 3. Okay, if we're doing branch if equal to 0, the select bits, I'm going to move into a little bit more of an appropriate spot. The select bits have to be 8 for the branch if equal to 0, because here it would look like an 8 in that 4-bit number. Okay. RD, there is no RD. So RD is equal to 0. RS1 is equal to registers of the argument of the, not the 0th, because that's where the instruction op is, but the first. And then the immediate, we could just say immediate equals register arg2. Delete this line here. We don't want to return zeros, we want to that should work, right? Let's try it. Let's put a branch if equal to 0, T0 0x05. Test ASM listing file. Okay, so what went wrong? Line 330, no, 303. Oh, that's what we did wrong. Okay, so the immediate is args2. Right, let's write you on that. Test ASM list. Okay, what went wrong now? 304. Oh, I'm done. It's not. It's gonna be when we pass the immediate. How do we do it up here? We did convert to int. Convert to int. Of that. Run that now. Test ASM list. Okay, what's wrong now? Okay. Sorry about that. Okay, just gonna lower the music a little bit more. Okay, so oh, I'm wrong. Oh no. If argument 2 is 2, oh no, we don't have to do that. We know the okay. We know that it would have to. Okay, so the 0th would be branch of equal to the source one. Oh, and then we need to tell it what to do for rs2. rs2 is equal to 0. So the opcode gets 3. Alright, so this should be 5 things total. Opcode 1, 2, 3, 4, 5, 6. Oh, 6. Yeah. Yes. Okay, that's right. Alright, because we have 6 fields in this instruction set. 1, 2, 3, 4, 5, 6. Okay. So we have 6 things there. This should work now. Run input file test ASM listing file. Oof, why didn't it not work? What do we do up here? Immediate equals convert to int args. Just copy this. I'm gonna just change this to. Did I have like too many brackets or something? Run. There we go. So let's see if it worked. So branch of equal, that's a 1 operand branch, so that's line op3. Cool. We are not using a destination register, so that should be 0. Source register, what do we put in? Is T0, which maps to register 1. And then there's no other source, so that is mapped to 0. The immediate gets loaded in there as 5. And then it's told that it wants to do the 8 there, which is this branch of equal to 0 right there. So beautiful. That worked. Now what happens if, for instance, we do this? T5. Oh shit, wrong one. S0. Test. I really hope it doesn't use the address of the. Oh, I did. Okay, so S. Oh, wait, did it? Wait, let me. Control C, Control V, and then do 0 to 5 again. Run test.asm listing. Okay, so this is right. Here. Oh, wow. Okay, so it didn't do anything with S0. It didn't put it anywhere because it didn't recognize it in the right format. So it just put in all zeros in the immediate. It didn't, right? Because like if we come up here, the address of S0, what I thought it was going to do there, if it didn't work properly, the error that I thought it was going to do is S0 maps to 6. Right, so maybe I thought maybe it would have put 6 in here, but it didn't. So that's nice to see. I should make it throw an error. So yeah, I should make it say if this, do that, else return zeros. Yeah. So I'm going to use this line here. We're going to pass in the second argument there, delete this. We're going to make that the second argument. And then we're going to say else return 0, 0, 0, 0, 0, 0. Returning 6 values. Alright, so if we're going to return 3 zeros or 6 zeros, if that's let's see what happens. This should encode as all zeros now. So we save this, run it. If I don't want an elif, do I? Oh, I'm dumb. Else run test.asm listing. Cool. It threw an error because that's illegal. And it thinks there's too many values to unpack. 1, 2, 3, 4, 5, 6. So I don't know why it's specifically throwing that error on that, but whatever. Okay, so now that we have that one done, the rest of these branch ops are really easy to do from here. So we have 3 more like this one. So for this one, this is going to be branch not equal to 0, so NEZ. It's still 3 operand, and then NEZ is going to look like 4 in the select, and everything else is the same. Then this is going to be GEZ, greater than or equal to 0. That's going to look like 2 in the select. Everything else is the same. And then the last one here is LEZ, less than or equal to 0. And that's going to look like a 1 in the select. Okay. So now if we come back into this, we should be able to do 1, 2, 3, and call this BNEZ. This one BGEZ, and this one BLEZ. And run test.asm. We want a listing file. Okay, so same immediate everywhere, cool. And now you can see that it puts 8, 4, 2, 1 there to tell it what type of branch we're doing, and then it's or what single operand branch we're doing, and then the instruction for a single operand branch is 3. And it looks like these oops, it looks like this shit here. Although I don't understand. There we go. Okay. I fucked something up there. So we've got all of those branch. Now we have 2 more branch instructions, but they are 3 operand. So we're going to do this. This is going to be branch of equal, EQ. It's going to be 4 operand. If it's not 4, we're returning zeros. The opcode now for this is 4 instead of 3. The select bit for equal to 0, or for equal, is going to be 8. RD is not used. RS1 is, and RS2 is also used then, which means we're getting register of RX2. This one we will convert from 3, and we'll change that to 3. And that should be all we have to do there. So we're doing a branch of equal. RS1 goes to RS1, RS2 goes to RS2, and then we're getting an immediate 2 in the third. So like that becomes this conversion here. That immediate is telling us where we're branching to, obviously. So we're now saying if RS1 is equal to RS2, then we're gonna branch to the immediate. And now that this one's done, we can do the same thing for branch not equal. Branch not equal BNE. So, but now this selection looks like 4, and everything else is the same. Okay, so we just did our branch ops. I'll select that. I still don't understand why it does that. Alright, now we'll call this jump. So we're going to have 4 jump ops. Okay, this is going to be similar to this. Alright, so now this is going to be jump J. And J is to, so opcode for this is 5. The select bit for this is 0. RD is unused, so that gets to 0. RS1 is unused. RS2 is the first argument pulled in. That's not the jump. And it's actually not, RS2 is actually equal to 0 if, oh, okay. So what I'm going to need to do is I'm going to need to come up here and grab this conversion here. I need to check if that's an immediate. So we need to say, oh, that's what this is doing here. Okay, so what we're going to do is we're going to say if the second argument happens to, and the first 2 are 0x, 0d, or 0b, then we're going to convert that second argument. Oh, no. Okay, so jump can't have either a register or an immediate. Jump just has an immediate address. Yeah, so we don't need it. So RS2 is equal to 0. Straight up. And then immediate will get that conversion. So now if we put in jump 0x05, that should work. If we put in, alright, we'll try that. Just run this. Test.asm listing. What the fuck? Oh. It's one, yeah, okay. There, one. Test.asm listing. What the hell? Oh, that needs to be one as well. This should work now. I say that every time, but list. Okay. So if we go to the listing file generated, jump, got that, and it tells it to jump to line 5. Cool, that works. Now if we put in, if we try to say jump and put in a register value, T0 for instance, that's just easy, it should fail because we need a JR to do a T0 like that. So let's try run this and test.asm, a listing file please. Failed. Cool, beautiful. So we get rid of that. But now what we're going to do is we're going to steal this. Alright, and now we're going to say rs2 is equal to args register of registers get square brackets, registers of args, and then it gets the first arg. And then we're going to say if that argument starts with 0x, it's wrong. And then, okay, and then we change that to JR, and then the selection for the JR is then making this 8. Okay, so now if we run this, we put in JR T0. Okay, and now you can see that it puts in that register as the source, and it's telling it that we're doing jump register by this being a 1 and that being a 0 for jump. Now let's try putting in jump register and then an immediate afterwards. It should return zeros on that. So if we do jump register 0x05, that's obviously not a register address. Run it. Test.asm lst. Cool. Key error 0x05. That at least helps a little bit. Okay. So we just did jump and jump register. Now we're going to do jump and link register, which are identical basically, except now we put in a RD source. So we're going to do this. We're going to call this jump and link. Jump and link. RD is going to then get registers of arguments. Here, we'll just copy this because it's easy. So I've got to put in the space there for consistency. Okay, so RD is going to equal registers of arguments of the first argument coming in. And then the second argument better be an immediate. Else we're returning zeros. Now down here, oh, and then what do we have to do for JAL? 0 is, okay, so selection is 0 for JAL, and the selection is 8 for JALer. So we'll just put in JALR like that. Okay, so that's fine. And then now we got to do the same thing where RD gets registers of arg1. This becomes 2, and this becomes 2. Okay, cool. So now we should be able to go and do the same tests. Here we should be able to do JAL 0x05. That should work. So we should be able to run this. Test.asm listing. Oof. Oh, okay. These instructions have 3 operations, or 3 operands, so now we'll rerun this and it should work. Should. Okay. And 452. Why is that too many? Jump and link. Args 3. Yes, there's 3 arguments, 0, 1, and 2. Oh. If the second argument, then we're going to convert it to that. Okay, that's what was fucked up there. Test.asm, please work. OST. A little closer. It says oh, I'm dumb. I'm dumb. I need to give it the linking register. So that's see, this error down here told me that there's too many values to it. It's really not enough values to unpack. That should change to wrong values. But at least it tells you it expected 3, so I only had 2 on this line, so I'll put in T0 as a destination register. And now we'll run this, and now it should work. So test.asm listing file, please. Cool. Okay, so now it's saying jump and link to this register here. Oh, and then the jump and link needs to change from op5 to op6. So then we'll come back in here and we'll change this to opcode 6 and change this to opcode 6, and now rerun this. Test.asm lst. Boom. Now if we look here, now we have a 6 there. Cool. And it's a jump, not a it's a jump to an immediate, not a register, so this is 0. That's why that's a 0 there. And okay, so now if we do the same thing, now if we try to generate an error by doing jump and link T0 S0, this should throw an error. Test.asm list throws an error. Cool. Now if we do Jaller jump and link register, we're jumping to the address held in S0, and we're putting the program counter there, so that should work now. Test.asm listing. Boom, that works. Okay, so now let's generate. Now if I try to do Jaller T0 and then we put in like 0x05, this should fail. Test.asm list file. Boom, failed. Cool. Okay, so we have jump register, jump and link register assembling. Now on to the RAM. Hey, wait, misprediction. That's Embazone, isn't it? It's been a while. I don't know what you said before the message got retracted. Oh, the music. Why did the music stop? Oh, did I get through all of them? Maybe. Okay. At least the stream hasn't ended randomly on itself like it has before several times in the past now. Okay, so now we need to assemble load word and store word. So we will maybe if I do this now, shit. RAM ops. This includes the I/O because the I/O is memory mapped. Excuse me. All right, so I'm gonna go back up here and grab like a larger instruction that had 4 operations or 4 operands, whatever. stick it down here, and I'll call this load word. Okay, for load word, opcode is 7. RD gets that argument. RS1 is unused. RS2 gets the second argument. Oh wait, am I doing load word? I wrote these wrong. This is RS2. This is RS2. This is RS1. Okay, so I'm just looking here. Load word. We're loading a word from RAM into RD. The pointer bus is RS2. The offset is that. So we're taking the RS2 plus the immediate and putting it there. And then for store word, we're going to store the word RS1 at the RAM location of the RS2 pointer plus that. So that keeps the pointer in the same spot. Okay. So now to do that, we need to then say so we're looking for if the first 3 args are in the format like this, 0x whatever, and then pull. So hopefully this does what I want there. So I'm going to search for the first 3 to be like that, and in the third argument, though I should be in the second. Oh boy, the way I parse the instructions, it just gets a comma separated list. It separates at a comma, so maybe I can make it. Oh wait, oh I know how to do that. I know how to do that. We'll separate it also at. Oh, it does separate on those already too. So it separates. I don't know. We'll see. Excuse me. We'll see what we have to do there. Not too worried about it just yet. Alright, so select gets 0 for the load word, store word. Then if argument 3 is actually argument 2. No. Wait, argument 0, 1, yeah, argument 2. So RD gets. So we're doing load word, so that means RD is used. RD is the first. Immediate is the second. So immediate is the second. And this is going to be arg3. And we're not, so we're using arg3 no matter what. So I think we should do that, right? So we're doing is RD gets the register destination, which is the first argument coming in. The second argument coming in here would then be the immediate, and then the third argument is the second source. So if I try doing load word T0 space 0x05 S0. Let's see what happens. It should, hopefully in theory this works. I don't know if it's gonna parse properly. Test ASM listing file. Oh my god, what did it do? Let's see. Wait, why is there 2 copies? Okay, that's an issue. if there's a space, it generates two. What the hell? Test.asm listing. I don't know why it's got two load. What? I don't know why it's got two load words there. All right, let's just ignore it, see if it's even right in the first spot. So yeah, it's register 7. RD goes there, which is T0. It's not working because this should be a 5. And it is putting S0 in the right spot. That's interesting. So the issue is, do I need a space? Test.asm rst. No, even with a space it didn't do it. So I don't know why it's spitting it out twice. Wait, what if I do now? Okay, it doesn't like blank spaces in the file. But now we need to get it to split on. So how do I do that? If this is going from 0 to 3 to grab the first 3 here. Where does it convert to args? Convert to int function? If I make that take in oh boy, how am I going to make that recognize? Alright, for now, I can do it the ugly way. Or the format for the instruction here, I could redefine it as immediate. Like, God, that looks like shit, but whatever. That's a lot less intuitive. So we're taking load word, and it's loading the word in RAM of rs2 plus the immediate. I don't know if I want to keep them in this format then. I might just reverse it to rs2 and immediate. I don't know what looks better. If I would have an instruction like this. Like, would this make sense? Like, I'm taking the global pointer, adding 5 to it, and loading that word and storing it into T0. Or I'm taking the frame pointer and adding 3 to it, and then storing that, and then loading S0 into the address of that generated for RAM. Like, I don't know. Like, I guess that's what I'll do for now. Yeah, maybe that's what we'll do. So we'll say load word. Get rid of this. Get rid of that. Get rid of that. Shit. Run a test.asm, a listing file. Alright, did that work? No, okay. So now we need to say why it didn't work. Okay, register destination is right. It's grabbing that. Oh, because I only need to check for the first two there. Input file test.asm list. Please put a 5. Yes, okay, put a 5 there now. So this 5 is added to the value coming out of T0, and then that stores the RAM address, the RAM value from that RAM location calculated here to register 1, which is called T0. Okay, one more instruction, which is store word. So do this store word. The first one here is going to be RS1, so RD gets 0. RD gets 0, and then we'll replace that here. RS1, RS2, still a third. Yes, and then so the only thing we need to do is change the output to being 8. And then that should all be the same. So now if we go here, store word, F0 X05. I'll show you. I could do 0D for decimal, and then 5, which would be the same. It doesn't matter. And then so we're going to store plus T0, I guess. So T0. So we're going to say we're storing the word S0 at the RAM location T0 plus 5. So we run this. Test.asm listing file. Boom. Okay, so now if I pull up on YouTube, or not YouTube, actually on DMs that I sent to. I need that link. Alright, 1 second. I just got to sign with Google. Okay, cool. Give me 1 second. The file is loading. Alright, so I'm just going to copy. Come here. And then we can get rid of. Oh, no. Okay. I was going to try to do all my other test instructions with this one, but all the registers I changed them needing a $sign in front, so we'll just do this. Anyway, so now if we rerun this assembler, test.asm, now I'll give it a binary, and there's our assembled. There's this here assembled to machine language. And there it is as a listing file, so it's easy to see what's going on. Yeah, this just shows you how it's broken down before it gets made as one single 25-bit number. So this is how I'm going to program the CPU. So basically, I pester Nano enough to write a plugin that places redstone blocks for me, according to the input string I give it. And I'll just go to. I don't know if you'd have a way of auto-generating the ROM, or if I would just do one line for me at a time and I would just paste it in one line at a time. That's okay if I even have to do one line at a time and just stand on top of where I would want it to paste in or something. Okay, so Aperture was saying if I want it to, if I want to be able to put a comment on like this and run this test.asm listing, and it generates an error. He says to do that, I would come to my asm to int function up at the top here, and where it's splitting here, have it split also asm is equal to asm okay, so he's saying right up here we add this line. So we're going to split it by the hashtags. I don't know if that'll work. Let's give it a shot. Test.asm list. Hey, holy shit. Alright, so if we go here, BLEZ. Okay, still did it, just ignored the comment on the line. Okay, cool. And if we then run this again, test.asm with bin, and we look at the binary format, that's line 7, so line 7, cool, no comment on it. Interesting. Okay, but now what happens if I do a comment here? Okay, so line 3 underneath SLT. Okay, so that's an issue. So for some reason it doubled itself. If you put a comment here, it doubled the line. But versus on line 8, it did not double line 8. But when you do the comment on its own line, it doubled it. That's weird. So I'll have to screw around with that, but at least for now, this is the full-on assembler without any pseudo ops. So like I can encode a no op as 00000, a move is like an add, and then like RD and RS1. Like so I can encode some more pseudo ops, but for now, I don't think I'm going to. I think what I'll do is align all this shit. And I don't know where then. Okay. Well, I'll save this, and I think I'm going to call it a stream for now. And then I will probably start working on the instruction decoder for the CPU either tonight or tomorrow. I'm just going to take a break for a little bit. Anyway, if you guys are still here and watching this, I appreciate you. Thank you for sticking around and being on this channel. Don't forget to join the Discord and then you know, like the video and all that junk. And if I could find my it's right here. I will end the stream. So thank you so much for watching, and stick around for the next one where we actually do the instruction decoding on the CPU so that we can then just feed it these instructions. Anyway, peace.